Okay, so our goal today is going to be to solve linear and absolute value inequalities. The solution to a inequality is a portion of the graph. So when we're solving these, we actually are going to have to graph them since our solution is part of the graph. Okay, so a solution to a system of inequalities is a region or an area on the coordinate plane with boundary lines. So the first thing we're going to look at are these inequalities right here. Now remember, we've graphed inequalities before. A system of inequalities is just graphing two or more of them. So this first one, your slope is -2 and your y-intercept is 6. So you're going to put a point at 0, 6, and from that point you're going to go down 2, right 1, down 2, right 1. On this one, you're going to put a point at 0, 3, so a 3 on the y-axis. Your slope is 1/2, so you're going to go up 1, right 2, up 1, right 2. Y is greater means you're going to shade above, and y is less than or equal to, you're going to shade below. So our graph should look like this. Now, once I graphed it, I'm going to show you a little hint of what I do. Notice the pink, the top equation, is dashed. The bottom one, the green one, is a solid line. When I'm looking at the pink one, I actually go through and say, okay, y is greater, so y is greater above, and I put in these arrows. And then when I went to go do the green inequality, y is less than, I put in these arrows going down. That told me that I'm not going to shade on this side of the green, and I'm not going to shade on this side of the pink. And since I had those post-its on there, it's really easy to now shade in the correct region. Okay. So next we have to determine if certain points are solutions or not. So the first one is 2, -3 a solution? So if I look over here and go right 2, down 3, the point's right here. To be a solution, looking at this graph, it would have to be a part of our shaded region. It's not a part of our shaded region, so from the graph, no, it's not in the shaded region. When we go to test this based on the inequalities, you have to actually break it apart into two scenarios. Okay, so I'm going to take this first scenario and I'm going to plug in the point. I'm going to plug in y is -3 and x is 2. So when I do that, this is what I get. Now from here, the left side, all it says is -3, so that's -3. On the right side, I'm going to plug that into my calculator. -2 times 2 plus 6. The right side is going to turn into 2. So what I have there is -3 is greater than 2. Is that true? No, -3 is less than 2. So when I answer no, I know that it's not a solution to the system. Because to be a solution to the system, it has to be a solution to both scenarios, both inequalities. I didn't even get to testing the green one here because it wasn't necessary to move on once I answered no for the first one. Because you have to have yes and yes in order to say, yes, it's a solution to the system. How about 6, 1? So I'm going to go right 6 and up 1. Now, unfortunately, my graph is off the paper here, okay? But I can see if I were to extend these lines more, if I were to extend this region, let's see if I can kind of visualize this. There we go. So it would still be within that region. 6, 1 would be right about here. So you can see that it would still be within that region if I extended my crayon, my shading, outside that graph. Okay, so from the graph we can say, yes, it is a part of the shaded region. When you go to test this with the inequalities, you go ahead and plug it into the pink one first. So our y was 1 is greater than -2 times our x. Our x on the point we're testing is 6 plus 6. So again, the left side there's nothing to simplify, but on the right side we're just going to type that into our calculator. -2 times 6 plus 6. And we get negative 6. So is 1 bigger than negative 6? Yes. And then we move on and we test the green inequality since it worked on the pink one. So when we test the green one, we do the same thing. Our green one was y is less than or equal to, y is less than or equal to. The y that we're plugging in is 1. 1/2 times x, 1/2, our x is 6, plus 3. Okay, the left side is still 1. On the right side, we're going to plug that in. 1 divided by 2 is 1/2 times 6 plus 3. We get 6 on the right. Is 1 less than or equal to 6? Yes, it is. So yes, it is a solution to the system. And that's how we answer that. Now, one more thing to think about here is if I had a scenario where I had 6 is less than 6, is that true or no? Is 6 less than 6? No. However, if I had 6 is less than or equal to 6, does that work? Yes. So make sure you know when it is included if these are the same numbers versus if it's not included if these end up being the same numbers. Okay? The or equal to allows you to say yes. If it's not, you have to say no. 6 is not less than 6. 6 is equal to 6, which is why here it says or equal to. You can then say yes. On this one, x is greater than or equal to 3. It's going to be a solid line. X equals equations are a vertical line. So it goes through the x-axis, a vertical line, through 3. The y is less than 5 is going to be a horizontal line. It's got to be dashed through 5. So through the y-axis at 5. So when we do that, it looks like this. Here is your horizontal line through 5. Here's your vertical line through the x-axis at 3. Now, I want to show you how I did these arrows. X is greater than or equal to 3. Put your pencil right on that line on the x-axis. Where are the x values greater than 3? Are they 4, 6, 8? Are those greater, or is it 2, negative 2? The 4, 6, 8 are greater, so that's why these arrows are going to the right. If you're comparing it to x, that's the only time you draw your arrows left and right. Every other time, you're always comparing to y, so you're drawing the arrows up and down. So for the y, what y values are less than 5? Here my y value is 5, but below that, they're all less than 5, so I put my arrows going down. Again, I used my sticky notes to cover up this part from the green and this part from the pink, and I was easily able to shade that corner of the graph. The next page of your notes on the back is going to be the absolute value functions. Okay, so y equals the absolute value of x is a parent function of an absolute value function. Remember, absolute values look like V's on the graph. So the vertex here is at 0, 0. So I put my vertex here at 0, 0. And that slope is that perfect slope. It goes up 1, out 1, up 1, out 1, up 1, out 1. I should probably put some scales here on my graph. And there I have y equals the absolute value of x. I'm just doing equations right now. These are not inequalities. We're just doing a recap on graphing absolute value equations. If the negative sign is out front, your v flips upside down. So our vertex didn't change. It's still at 0, 0. Put some scales on here. And it's going down 1, out 1, down 1, out 1. Until you run out of graph. Use a straight edge, connect them, and you have y equals the negative, or the opposite of the absolute value of x. Okay. This one here, y equals 2x plus 4 minus 3 on the outside of the absolute value bars. So to find the vertex, remember, you're going to take the inside and set it equal to 0. So the inside is 2x plus 4 equals 0. Solve for x. That means our vertex is at negative 2 comma something. Let's figure it out. If I plug it in on the inside, 2 times negative 2 plus 4, the inside then is 0. The absolute value of 0 is still 0. 0 minus 3 is negative 3. So you're just going to plug in that x value to figure out your vertex. So now I know that my vertex is to the left 2, so let me put a scale on here. Left 2, down 3. Okay. Now, my slope is always going to be the number that's in front of x, or even if it's on the outside. Like this slope is going to be 2, and this one's also going to be 2. It's the number closest to x. Okay, so that tells you that you're going up 2, out 1. Up 2, out 1. That tells you how steep that V is. This is all from Unit 2. So this is review. If you didn't remember that, you could resort to making a table. You could also resort to graphing it on a graphing calculator, if you have one. On this last one, again, set the inside equal to 0. So x minus 1 equals 0. X equals 1. So our vertex is at 1, comma, plug it back in. 1 minus 1 is 0. The absolute value of 0 is still 0. Times that by 2, you're still at 0. 0 minus 3 is negative 3. So this vertex is at 1, to the right 1, down 3, right there. I should put some scales on here. Now this slope is also 2, so I'm going to go up 2, out 1, up 2, out 1, 2, out 1. I'm going to connect it with a straight edge. And that would be my absolute value function for this function. Or my absolute value graph for this function, I should say. Okay, so then when we go to do this one, again, you're going to take that inside, set it equal to 0, solve for x, and that'll tell you where your vertex is. So negative 3, comma, plug it back in. 2 times negative 3 plus 6, the inside is going to be 0. The absolute value of that would be 0, so I have negative of 0, which is still 0, minus 2. So negative 3, negative 2 is that vertex. So negative 3, negative 2 is that vertex. Actually, I'll make this color. Okay. Now this one has a negative sign on the outside, so we know that it is opening down. And our slope is 2, so it's going to be opening down and out. So we go down 2, out 1. Down 2, out 1. This is or equal to, so it's going to be a solid V, not dash, solid. And it's less than, so we're going to be shading down from all of these points. X is less than or equal to negative 3. So x equals is a vertical line, so this is going to be a vertical line. Double check, is it solid or dashed? Solid. And then remember, this is the only one that when you look to it, it's either left or right because we're looking at the x-axis. So are the values -4, -5, -6 less than -3, or are these ones over here? And it's going to be to the left. So I'm going to use my Post-it notes. I'm going to cover up on this side of the green. I'm going to cover up on this side of the pink. And that region right there is going to be my solution. This one here is the absolute value of 2x plus 3. So again, we are going to take the inside 2x and set it equal to 0. You're going to find that x is 0. So our vertex is at 0, comma, plug it back in. 2 times 0 is 0. The absolute value of 0 is 0. 0 plus 3 is 3. 0, 3 is going to be our vertex. So left, right, 0. Up to 3 is our vertex. This is going to open up because there's not a negative sign in front of it. And that 2 tells us it's going to go up 2 out 1 every time. This is a solid V because it's or equal to. And since it's greater than, we look at all those points and it has to be shaded up. Y is less than 2x minus 5. The y-intercept is at -5. 2x is up 2, right 1. I get all those on there. And that's going to be a dashed line. And then y is less than, so these go down. Now, when I go to, look at this, the arrows are going in opposite directions. If I cover up everything down here, you don't even see that green. And there's covering up the green, you don't even see the pink. So there's no way for you to arrange these Post-its and allow you to actually do any kind of shading here. So our final solution is no solution because there's nothing in common that we can shade to be a part of our solution. So in this case, that's no solution because there's no overlap in our shading.